If you look at how modern web development with frameworks looks, you can see that you think in terms of components. So you bundle together the template, the styles, and the logic for your component in one file. Whereas when you develop vanilla HTML, that's not really possible, as for example with the HTML file. You have to put the whole document in one file and can't easily just import part of HTML or something. You could, for example, make a button JavaScript file, but mostly you also have every styles mixed and so on. So you see there's really a difference in development workflow. Until recently, so this is nothing new, web components. It's also vanilla HTML, or basically a browser standard that allows you to develop native components for the web. And you might argue, yeah, why should I look at this? I only do React or Svelte, and in this case, this is totally fine. You don't really need to look at web components. But the thing is, if you have a big corporation and you need shared components, and big corporations don't have like a landscape with only one technology, they have lots of technologies. Doesn't even have to be the frameworks here, can also be some Java web apps, some PHP apps. And that's not really doable to import a React component in your PHP project. So their web components could also be a major role to make something work for every app, also for the future. Also, they're shareable, so you can import it from other creators. And another aspect is if you have some off-the-shelf solutions where you can develop plugins for where you don't have access to the code, for example WordPress or Oracle Apex, then you can develop plugins for them to extend the functionality to your needs. And there it also makes sense to develop web components, as they have a really nice to use API, and again you just think and develop into the terms of your component. And what we're building here now is this kind of pool measurement component where you input the measures of your pool and you can click calculate, and it's going to return capacity and surface area. And we have some options. We can change the units, and yeah, we're gonna build it step by step. So let's start with the basics. So here on the left side, I have a HTML file, and it's basically empty. So we have this empty app div, and in terms of reusable components, we have to define our HTML structure. So that's what we already see here. It's inputs and some text, a button, output text, etc. And we want that reusable, so we can use a JavaScript file that we load here, and we can create an element of the type template. So template is a real HTML tag we can use, and we give it an ID and some inner HTML, so we can then just put a string in there, and that's basically the HTML layout with here styles and the markup of our template, of our component. And then what we're gonna do is query our app div. So this is the empty one in here, and we can clone an instance of this template.content.clone node true, and then we can append it to this app div. And that's what we see on the right side here. We have below this app here, we have our style tag and the input section, output section. That's this part. So just copied the HTML. What I can do is I can do another one, and now we have this duplicated here. So I can make lots of these. And so this is a step to make HTML structures reusable. Another improvement we can do is create a custom element for that template. So again, we have our template definition here, still the same. But below we define a class, we call that pool dimensions. It extends HTML element class, that's from the browser. And in here we do a constructor. We always have to call the super function here to initialize the parent constructor, an HTML element. In here now we clone the template, and then we call this .append child template clone. And below that, we also run custom elements.define pool dimensions. And by that, we say, okay, this HTML tag pool dimensions is now an instance of this class. And this class on constructor just appends the template to itself. So if we look at the HTML file, notice that we load the script before the body. I just put a div in here, app, and then use my defined pool dimensions element. And on the right side, you can see this is now a custom element here. And I can go ahead and see that in there our structure is there. And I think that's a way better API. So it's not fairly easy for myself to make multiple instances and to develop my main page instead of doing these JavaScript calls we did before. Another thing that might be important is encapsulation. So as you notice in the template here, I have used IDs, and IDs have to be unique. And if we want to use this component multiple times on the same page, then we would get a problem because the IDs wouldn't be unique, they would be duplicated. And it would be better if we don't have to care about this. And we can do that with a shadow DOM, which offers encapsulation. And inside our class here, first, before we clone the template, we create a new variable, this.shadow, and we assign it to this attach shadow mode open here. And then we clone the template again, and then we append this to not only this, but this.shadow. And here's the rendered app. And what you can see here is our element, and in there there's a new node called shadow root open. And in there is now our app, our template. And so that's an encapsulation layer. You can access the child from the outside. So this is from the parent document. I can say query selector, pool dimensions, then .shadow root, .query selector. So I can access and also change something in there. If we don't want to do that, we can change this to closed. And if I run that again, I get an error. Shadow root is basically not defined, or the query selector on it. But let's redo that. You can decide for yourself if you want this to be opened or closed. And another thing the shadow DOM does is actually encapsulates styles. So for example, I'm on the parent page and I say, okay, every label on this page should be green. So let's add an A label here. And you can see it's green. Inside this template, we also use labels, but they're not green. That's because of the shadow DOM. They will basically make it sure that the styles won't be applied. So also means like if you have classes outside, they won't get applied in here. So the styles are really encapsulated also. One thing that goes through the shadow DOM is custom properties. So CSS variables. You can define them from outside and then access them from the inside. So until now we didn't add any functionality or logic. So we had this button and it didn't really do anything. And to do that we can add event listeners, of course. And we can do that in our class, in the constructor. We can, here after appending the template, we can first here, let's get the length input. And then we have these two buttons. I added another one here. And just this.shadow.query selector. I get them by ID and I have them saved then in a variable on this context. And I, here in the constructor, add an event listener for this left button on click. And I call this.log click, and this just logs clicked, which button, and the length, the current length. So this works great. Thing is, when this component gets removed from the page, we also need to remove the event listener. For that we have the diconnectedCallback. That's basically a life cycle function from the web component, and it's invoked each time the custom element is disconnected from the document's DOM. We also have connectedCallback, which gets called when it's connected. So this can be after the constructor is called. And so I click on calculate here and we get this log message. I've also like this second button. This is invoked in the connected callback. And when I click that, I also get that. So you can see also here first the constructor get called, then the connected callback. So one problem is when we move the element. So I have this another button down here, a move element and a text before that. And if I click the move button, I will move the component with the move target function, this move target is this text. I will call move target dot after, and by that I will move our web component below the text. And if I do that, you can see it, text is now on top of that. You can see that the calculate button didn't work anymore. So we called the disconnected callback, as we should clean up after ourselves. We unregister the event listeners here. But the move removes the element and adds it back. It doesn't call the constructor again. So we don't add that event listener again. So this one has no event listener currently. Whereas the connected callback is executed again because the element was attached again, but not reinitialized. So the constructor doesn't run, but the connected callback does run. And this one does still work. So I would recommend you can define like your elements in the constructor. I like to do that. But if you want to add event listeners, add them in the connected callback and then remove the event listeners in a disconnected callback. Another thing that's quite nasty is this line of code. So we have this function log click below here, and it's just doing the console log here. And we add, because we access here the input value of the length, so the 2 here. And we need to basically access this context. But if we call add event listener and pass this function in there, this context in this function will be overwritten by event listener. So this context is then basically the event target. So let's log this. So again here, this is our component. And if we remove this bind here and call that, this is the button that's calling it. So we can't access our input anymore. So that's why we have to call this function. So any function you have in here where you want to access any of the components, this attributes, and you pass it to an event listener. So not every function overrides it, only some. You have to remember, and I hate this, to call this log click, basically override the function with a function, but you bind this to it. So you say, I don't care who calls you, this is always the current this, the components this. And I don't really like it, but keep that in mind, it's a really bad trap. So now I cleaned up and I have only one button again, and this is the event listeners added in the connected callback. Like I recommend, I also bound this to the new calculate function, and if I go ahead now, enter something, click calculate, we get our results, and the calculation is fairly simple. We just get the input values, capacity is length, width, and depth multiplied by 1000, and area is just 2 times basically walls plus floor. So I don't know. 2 times because each side is 2 times, and floor. And we then just write the output to the text content to our these element here. So another thing that would be nice is for people who don't measure length with a measuring tape, but with their feet. I'm just kidding. For American people or British people, they measure with the feet unit, the imperial system, to support their things. So also not gallons, but liters, or other way around, and square feet. And how we can achieve that is if you look like for other elements like input, you can assign attributes to them. So for example, this input here, the length input, is of type number. So we say, okay, treat this one so that you can't actually write letters, or you have this increase and decrease controls. Also we can do min, we could do required, we add classes. So attributes let us control the behavior of some of the elements. And it would be cool if we can do the same for our component, that we just pass, okay, units, this one is metric and the second one is imperial. And good thing we can actually do that. But first things first, we have to care for a template. So here I just added spans for all these labels here. So we can dynamically change that. So we have length units, and we have area units and capacity units for liters and square units. And in the constructor, I also selected them. Notice that the length units we need to select are all, because we have for length with depth 3 times that unit display. And then we have the set units function. And the set units function, we can access that passed attribute here. So for example, here we pass metric as units. We can just retrieve that with this.getAttribute units. If we don't pass anything, we default to metric. And then we do a switch case and assign this.isMetric to true. And then we're just going to change the label of the display here for each unit. And then we do a recalculate. If we already have some values in there, we can then do a recalculate, because gallons and liters are different. And this method, we do call that in the connected callback. So then, for example, in the second one here, on render, it already has a feed thing there. Because on render, we call the logic to change the units. And we also need to change a little bit the calculation. So like here, if we input now feed, the square feet is the same calculation. It's just only different unit, but like gallons and liters are completely different. Here we actually have a if condition. If this is metric, then I just multiply this by this value where we can convert liters to gallons. And this works great. So we just render this one here, and they are completely they are the same component with different settings, basically. Well, also one interesting thing is could we change how this behaves during, like now, after we already calculated, when it's already rendered to the page? And of course we can do that. We can just query our element. I've gave it an ID because we have 2 of them, and then we just can call set attribute units. This is now metric to imperial, and voila, it's changed. So even when it's already rendered, we can change that. How we can do that? So first, on the top of our component, we have this static get function. Static because we can't change that anymore, and get functions are like object-oriented thing. I think you don't see that a lot of JavaScript, but it's a getter for this class. And observed attributes is just a default thingy. And here we just return an array of the attributes we want to be observed. Observed is like reactive. So if something changes, so if we change this unit thing, then our attribute change callback, which is also a lifecycle method here, attribute change callback, this gets called, and we get 3 parameters. First, the name of the attribute, old value and new value. And then we can do a switch case on the name. So if we have 5 attributes, can then check, okay, if it's the units are changed with that, if maybe, I don't know, numbers are changed, the input numbers or something. If we would have the attribute, you can also handle that. But here we have only the units. And I don't need old value and new value. They're really useful, but I'm in this function. I already asked for the current value because I also call that on connected callback. And that's also why I call recalculate here again, because so we can then change the calculation here. So if we go back to metric, you can see the gallons now is liters and the values changed. So we need a recalculation for that. Yeah, and that's how you do attributes. So now we want to pass like default values here to our instance of the component, and that on page load basically. So the user doesn't have to type his values again if we already saved them in a database or something. And of course we could just use 3 separate attributes for them, length, width and depth. But at some point, if we add more and more parameters maybe, this would be tedious. So we might want to just pass an object. And objects can't really fit in attributes. Attributes are, or basically they are in XML structure, and XML does support strings mostly, and not JSON or objects. So for that we have another thing called properties. And this can get a little bit confusing because it almost works the same as attributes. But if we look at it, so this one, if we reload, it actually gets the values. And you can see it gets them after a while because I added a timeout here. So I call it set timeout here, half a second delay. I just grab the instance of my web component and then I say dot data equals, and I pass an object with length, width and depth. I can change that to 4 and you can see it's now 4. And it's called property because basically data is just a property on our instance. And in the component, how can we access the properties? Just like real properties, like this dot data. And so this is in a connected callback. We check if at that point already there is some data, and then we set the layout. So this does not work reactive like our observed attributes do work, but we can change that. We can add getters and setters to our property. So get, name of the property here, data, and when we say get, we just return the current value of the input, and when we say set, then we receive the 3 values, and we just set our inputs to these values and call calculate. So, and that's the confusing part. They do the same. The only difference is that they're not in the HTML, so we never see the values in there. Is it in here? Yeah, we only see the units part here, not the data. It's not, that's the difference between attributes and properties. They're not in the HTML, but they work on the code differently. So here we do these getters and setters, and we have this dot, where with attributes we have this dot get attribute, we have the get observed attributes where we say which is reactive, and we have the attribute changed callback here. And that's what I dislike about it, is that they work so differently. And But besides of that, they're really useful. You should use them where you can. And so you can see here, I can, for example, increase the width, and I can, because the setter does look into the input, I get the updated value. Now I get 10, because again, the getter looks live in the input. And I can also do 10, 10, 10, and then calculation gets changed. Great. And the thing with attributes and properties is also, so the attribute units is still here. So I just log the value of the get attribute units thing, and this is metric. And if I look at the property units, it's undefined. And I can then say the property units is imperial. Nothing happens because I don't use a property, and the attribute is still metric. And yeah, so they're really separate things, and it can get confusing if you don't know which is an attribute, which is a property. But there is one thing you can do to make them in sync. So I have another web component example here, and it's just every second there's a new number displayed. And if we look inside the component, I have this attribute changed callback, and I just, it has one attribute, it's called prop1, and it will get the number from the outside, and it will call this setText, and this setText just put it inside here. Interesting part is that in this interval that always generates a new random number, it's random if it uses a property, the property with the same name, or the attribute. So basically I've synced the property with the attribute. And how does this work? So just the attribute always triggers the attribute changed callback, so we don't have to do anything for that. But the property setters and getters are the thing here. For the getter, really easy, I just return this.getAttribute prop1, and for the setter, I just call this setAttribute, and this will trigger then attribute change callback. So fairly simple. You can also look at the DOM here, and we can see each time, doesn't matter if it's changed by property or by attribute, we will always change the attribute so that the both are in sync. So the last thing I want to look at is slots and also private methods. And slots is a way to pass outer content, basically any elements, into your web component, so you can render them as children. And this makes sense, for example, in this modal component here. So the modal component should just be a wrapper for any content to be placed in a modal here, in a dialog. And we don't want to care anything about the content of this. So how we do it, we have this template here. It's just a dialog. It's a fairly new HTML element. And what we do here, we have a main in there, a header, a footer with a close button. But in the main, we only have a slot. So it's an element called slot with a name content. And this is just the content we want to display into our dialog. In the parent page, we have our my dialog component. We have the attribute of the title. So we can change hello YouTube. And this is changed. And we then, in the children, we do a div and say slot. So we don't do a slot element, we do a slot attribute here and call the name of the slot. Because we name them here, we can also do multiple slots. We can, I don't know, do a tab component there. It would make sense, I guess, to do multiple slots. And so now we have this dialog, but from the outside we control what's in there. So we can add a button here. Click, doing nothing, but it's now in here. And yeah, that's basically it. We just do the slot thing, and we don't even have to care about anything. So it's the only time we actually use this thing is inside this template. It's automatically handled. We don't need to call any JavaScript. Next thing is, so we have this open function here that opens the dialog. But the thing is, the button to open the modal shouldn't be in the modal because we can't see it. We have to open it from the outside, from any other element to see it. So how we can basically call the open function that's in the component from the outside. And that's fairly easy. So all the methods we define here are callable from the outside. So I can just say dialog is document query selector, my dialog component, and I just can say button at event listener dialog.open. Can also do, if it's open now, I can just do .close because it has this close method. So you could argue, okay, does make sense, but what if I have a private method? And this is possible. So here we have a private method, and we do that by prefixing it with a hash just. So first character of the function name must be a hash. And then we just do a console log private method. And actually all the time, if I click open, I call this private method open. And this works from inside the component. But what if I have the second button called private method, I will add event listener click, and then I get the dialog and call private method, I get an error. So why did I wrap this in this evil statement? Because actually it would already throw an error if the page loads. So private field, private method must be declared in an enclosing class. So it basically says, yeah, you're not inside that class, you're not a child or extending it, or you're not allowed basically to call this private method. So yeah, that's how you do private methods and how you use slots. Thank you very much for tuning in. I hope this helped, and I hope you have some value in web components. I like to keep that in the back of my mind because when doing components that I need in different environments, different frameworks, that's the go-to route. There are also libraries for web components. I think it's webcomponents.org. It's not as big as I like, but here are a list of already built components that you can actually find. Maybe just implement. That's actually looking awesome. Didn't know that. Okay. So check that out. If this was too fast or something, I also have a blog post linked below. I also have like every tutorial I showed you linked inside a GitHub project below. And if you have any questions or feedback, please let me know in the comments. Thank you very much for tuning in. Enjoy your day.